here's the UML. We're going to dive into the code in a second, but this is the overall UML. And for this, right, we basically just have our solve towers, which is our testing area where we, it's entry point to our program. And then we have towers of Hanoi, which is going to be our object, right, or our class, right, that contains the actual methods for moving and simulating what's going on, right, how many moves it takes to get from one tower to another. So let's go ahead and jump to the code. So we're back over in the IDE. And now we're looking at solve towers, which is a class that basically just contains our entry point. So it creates a towers of Hanoi object, and that object, right, when we create it, we're going to tell it how many disks it has on top of it, right? How many disks do I need to move from that first peg to that last peg? So we set up our tower, and then we do a solve on it. And over here, I've actually already run this thing once, so you can see the output, right? So the output is going to tell me, move a disk from peg 1 to peg 2, from peg 1 to peg 3, from peg 2 to peg 3. So it's giving me that trace, right? What disks do I need to move around in order to solve that puzzle, right? In order to move that entire tower from the first peg to the last peg. So it's printing out all these moves that need to be made. So we have that there. Let's go ahead and look over at the actual implementation for this thing. So over here, we first have our constructor. The only thing our constructor does is it takes in the number of disks in the tower. And it just stores that as a member variable, right? So it's going to store the number 4 over here. So let's look down here. We have now the solve method, right? So this is what the other class is going to call when we want to actually go and we want to simulate this tower algorithm, right? So over here, we have move tower, which is going to be the heart of what we're doing. And this thing has 4 parameters. So the first thing over here is the number of disks to move. Initially, that's going to be total disks, right? Because we want to move every single disk that's on that first peg to the last peg, right? So we want to move 4. Now, these other 3 parameters, what they're doing is they're controlling the kind of the purpose of the other pegs. So 1 is going to be the original peg, right? The origin peg, right? Where do those disks start before we move them somewhere else? So this is just saying, hey, all those disks started on peg 1. The second parameter here is where those disks should end up on. Well, because of the way the puzzle's defined, we want to put them on the third peg, right? So we need to move them all the way over. The last parameter here is the temporary peg, right? So we have to have some peg that we can use as a sort of a buffer to put stuff onto, right? We need to kind of jump back and forth, right, as we move things around, right? We need a temporary holding space for the disks, right? So that last parameter there is where we should do that, right? So it's saying, okay, use that middle one as the temporary. So this is how we get started, right? This is what starts off everything. So let's scroll down and look at the main method that actually does this. So over here, I have move tower. The other one I have here, I guess I'll mention it briefly before we go to this one, is move one disk. So this is a method that is meant to simulate us moving a single disk. And really all it does here, since we don't have kind of a complex data structures, we don't actually have a game behind this, all it really does, right, is it prints out, move this disk from this peg to this other peg. That's all it does. So it's kind of straightforward. So going over here, looking at our move tower. So our move tower method, right, is the method that's going to actually take a bunch of disks on a particular tower, on a particular peg, and move them over to another peg based on some temp. So over here we have our base case, right? This is the first thing we need to check, right? Well, is the number of disks I'm moving, is that equal to 1, right? Am I just moving one disk over, right? If I'm moving one disk over, I don't need to do any kind of bookkeeping, right? I don't need to move a bunch of disks to some temporary, then move this other disk, then put them back where they came from. I don't need to do all that stuff, right? I don't need to do that kind of 3-step process. If I just have one disk, I can just reach and move it over. So base case is one disk. So if I have one disk, just run move one disk, right? Which is going to print out, move the disk from this peg to this other peg. So this is kind of our simple case here. Otherwise, go over to here, and what we'll do is we'll do a move tower on n-1 disks, right? Number of disks minus 1. So we're moving that little tower, right? We said we would move all but the last one to a temporary pole, right? And that's what this line is doing here, right? It's starting at the first pole, right? Peg 1. And then over here, right, this is the second parameter. Well, the second parameter represents where all those disks should end up, right? So here when we pass in temp as the second parameter, what this is really saying is move everything from peg 1 to peg 2. And your temporary, right, is the last variable. So the temporary peg that we can use while we're moving stuff around, that's peg 3, right? So overall, this whole thing, right, if we call this for the first time, it's going to move n-1 disks from peg 1 to peg 2. So if we have that, then that means that there is one disk left on the first tower, n minus 1 disks on the second tower, and the third tower is free. So in that case, we move one disk, right? So we take one disk from peg 1 to peg 3. Put it in its final position. Now that we have that, we have n minus 1 disks on peg 2, one disk on peg 3, and nothing on peg 0, or peg 1. So our last step then is to take n minus 1 disks from peg number 2, right, that temporary one, and move it to peg number 3, right, move it to where it belongs. And in that case, our temporary is going to be peg number 1, right? So again, this whole idea, right, is that in order to move everything from the left side to the right side, what I'll do is I'll move a slightly smaller tower to a temporary, move one disk into its final position, then move the temporary onto that disk that I put in its final position. So that, at a high level, is how this algorithm works.